these are the movies there that, and I'll just, yeah, come on, Ian. There we go. So here are the movies there that, these are all links here. I forget who was asking me there about the RAM. I didn't write down your name, but hopefully there you hear this. You contact me. Let me know which 7 it is, and well, I'll get those fixed to you there because respiratory is important. I think you said there that there were 7 movies in the respiratory section, so we'll have a look at that. And any updates there from you guys would be appreciated if it's accessible or not. And but yeah, we're doing all right. This PowerPoint here, it's really not that bad of one. What do we got? We are now, yes. And here we go. This one here I actually wanted to do at the start of the course. It kind of worked well with another section at the start of the course, but some of it is, you really can't do this section until you've covered all the organ sections. So, and you have. So let's have a look here. What we're talking about is water, electrolytes, and acid-base balance. It's not that bad of a lecture here. It's only 20 slides or so. So, the alternative formats. Okay, that looked like good something. I'll read that, Joanna, in a little bit. All right, and please, if you guys have any questions at all, stick around there at the end, and we'll talk to you guys about it. It's all good. You guys are doing good. So, describe the 2 main fluid compartments and the composition of body fluids. We're going to define intake and output. Not too bad. Explain the effects of water imbalances, fluid shifts, and fluid spacing. This one here, maybe you didn't know too much about. It's interesting. Water can hide all over the place. We're going to list factors that affect the electrolyte balance. Describe the most common ions found in intracellular and extracellular compartments. 3 mechanisms that regulate pH. And we're going to discuss the acid-base imbalances. These 2 here are good ones. Acidosis and alkylosis. So you just have a look here. This is just kind of a little cartoon of where all your water is hiding inside of you. And as it turns out, you know, interstitial fluid, the plasma, the blood, the lymph, all this is only, what's that, 37%? Extracellular fluid. So blood and plasma and lymph and all this kind of stuff moving around. It's only 37% of the juice that's in you. 63% of the water is trapped inside of your cells. Okay? So we have extracellular. You got sodium, chlorine, and bicarbonates. Okay? Intracellular components of body fluid. Here we've got the potassium, which generally is on the inside. You got phosphates and you got magnesium in there. So these ones here tend to be outside the cell. These ones here are inside the cell. And you'll see this one here. You get the carbon dioxide from the cells into the blood. There's an enzyme there that changes carbon dioxide into bicarbonate. And then this one here acts as your pH regulator en route to the lungs. Yeah. Generally, we should be drinking at least 2 liters of water a day, 2.5 liters of water a day. Okay. You can get water from other methods there. You eat an apple, eat an orange. There's lots of water in there as well. So your output there is about the same. So you're drinking about 2.5, 3 liters of water a day. You're peeing about the same. Right? Because you want to keep it the same, right? Output there, it leaves the kidneys, the skins, the lungs, the digestive tract. It's all regulated there by the kidneys there. We just covered that there. And water balance intakes. Your intake should equal your output. And you can see here how we lose water, we gain water. You'll see here. Sorry the slide isn't that good. Water gained through metabolism there, through food and water and all these kinds of things. Then we lose water here from sweating and eating and all these kinds of things. So it's a great slide. Dehydration, not enough water. And you can do these experiments there with the kids. You can take a carrot, leave it out for a day or two, and watch it become kind of, what's the word, flaccid, you know what I mean? Because it's lost its water, right? So the cells inside the carrot have shrunk, right? And now your carrot is kind of wonky and bendy. But then you put the carrot back into a glass of water, that bendy, flaccid, dehydrated carrot, put it back into the water for a day or so, and then nice and crisp and all that. So, edema, okay? Excess body water, okay? And what we're talking about here, maybe there's a sudden weight gain. And you know what I mean? The if you're dealing with elderly people or dealing with anybody, you know what I mean? Outside of going to an all-you-can-eat China, like Asian buffet or something like that, which I actually miss. I miss the Mandarin. I can't wait for that. It's probably why I've lost 20 pounds. Maybe I shouldn't miss the Mandarin. I don't know. But outside of going to an all-you-can-eat buffet, we really shouldn't be gaining, a pound or two in a day. And conversely, you can actually lose a pound or two, maybe 3 in a day. Like boxers, they to try and get the lowest weight before they enter into their fight, what they'll do is they won't drink water for 24 hours, and they'll just wear a hoodie and track pants and be on the treadmill for 5 hours. And they'll drop 10 pounds in a day, and it's all water, right? So not really that safe to do. This is interesting. Fluid spacing. And you know what I mean? It's a nice little paragraph there in your book. And yeah, have a look at it. Give it a read. It's talking about first spacing. This is where the water normally goes. Okay? Where the water normally goes, this is where it's supposed to be. But you look at this one. Interstitial edema. Now what this is where water isn't supposed to be. Okay, transcellular. Now, in this kind of a case here, it's rectifiable. We can get rid of the water, but it takes treatment, either with drugs, through diuretics, these kinds of things. But if water falls into the second spacing, we can fix it, but there's a process. And then, if water gets into the third spacing, okay, we really can't get at it. Ascites here. You've got water in the digestive tract. And read that little section. It's not very big. I think it's only a paragraph in your book there. But it goes into first, second, and third spacing of water. Not difficult. Have a look at it, though. Here are your electrolytes again. You guys have seen these there. Your sodium, chlorine, potassium, bicarbonate, cation. You guys will remember. You remember us doing all this there? It seems like a million years ago, doesn't it? When we were doing our chemistry. Cations are all positively charged. Anions are all negatively charged. Okay. Examples of electrolytes. This is sodium chloride. This is salt. And when you break it up, when you eat it or put it into water, it breaks up into 2 specific ions. All right. Here we've got potassium chloride. Here we've got sodium bicarbonate. Okay. And examples of ionization, like I just said there. Sodium chloride breaks up into its 2 ions. Okay. Major ions and their function. Okay. You guys will know this there when you got any type of muscle, nerve, all these kinds of things. Ions are absolutely crazy important. Okay? Chief extracellular cation. So this one hangs outside the cell. And you remember you'll have your sodiums on one side, your potassiums on the other. And when there's a nerve firing, what happens is they switch, right? That's where you get your energy. Or that's how the nerve travels down, right? And then we need to reset it. And that's where we need to eat a banana. Because the banana gives us the ATP, which then resets that to the sodium and the potassium. And then when we want to fire a nerve, that's how it all goes, right? So there's your potassium is your intracellular cation. Okay, nerve and muscle function, we've got them all here. All right. Calcium, we've done the, and again, strengthens the bones and the teeth. Well, it does a little bit more than that, right? So we've talked about calcium. A good one there to know. I'll definitely get you on a question or two on the final about, remember the thyroid and the parathyroid, calcitonin and parathyroid hormone, the regulation of calcium. It's very, generally as hormone systems go, that's a nice one to know because you've got the thyroid and the parathyroid. One is taking calcium out of the blood, putting it on the bones. The other one there is taking it off the bones and dumping it into the blood. It's a nice little opposing system. Know that one. And if you didn't know that one, there you go. Magnesium participates in nerve and muscle function. You've got chloride, bicarbonate. You guys have seen this there for the respiration system. Okay. It's what we, a buffer. Now, a buffer in chemistry is a compound that we can add to a system that, so I have a system, let's say I have a glass of something and I've added some buffer to it, whatever. Now this system has been unquote, quote unquote, bufferized, which isn't a word, I just invented it. Now I can add acid to this system and the pH will not change. I can now add base to this system and the pH will not change. So a buffer is a substance that resists the change in pH. Okay? Because when we're talking about the blood, there is not a lot of room to play with as far as pH goes in the blood. All right? You'll remember there that an acid means hydrogen. Okay? An acid just means excess hydrogen. It's the excess hydrogen that gives lemon its tang, that gives vinegar its tang. That's the hydrogen there. And too much hydrogen will burn a hole in your tabletop. When we're talking battery acid, these kinds of things. Look at your stomach acid. It's hydrochloric acid. Okay? You drop a banana in there, in 10 minutes, man, that banana is just completely dissolved, broken down, right? You'll remember there your pH system goes from 0 to 14. The 0 to 7 is an acid. 7 to 14 is a base. 7 is neutral. And look at where your blood is. 7.35 to 7.45. That's your blood pH. And it doesn't vary outside of that. Because if it does, then you're in big trouble. Okay? And generally speaking, 7.35 to 7.45 when is really, your blood does not change pH because it has buffers in it. That carbon dioxide coming around on its way to the lungs gets converted into bicarbonate, which now acts as a buffer and keeps the blood within this mainframe. 7.35 to 7.45 is an amazingly small range for a pH. Incredible. Okay? So you'll see here that the buffers, okay, the first line of defense against regulating pH, Okay, the lungs there, the second line of defense, and the third is the kidneys here. So the buffer is so important for maintaining blood pH. Okay, you have a look here. Buffers chemically resist change in pH, stated there before. Lungs regulate pH by changing the rate of respiration. Okay, and the kidneys regulate pH by excreting and retention of these guys right here. Okay, we can dump hydrogen, get rid of it if we need to. We can keep hydrogen if we need it. We can dump bicarbonate if we need it, or keep it. All these kinds of things, and it changes every day. Buffers maintain normal pH, always work in pairs. One part of a buffer removes hydrogen, the other part donates a hydrogen. They don't change everything, they just kind of change things' availability. So if you've got all these hydrogen and you remove them from the equation, the hydrogen are still there, but they're just in a different form, and so they are not making acid, which is what you want, right? The buffer system there's your bicarbonate, okay, from your CO2, and you can see it all in here as well. For instance, if excess hydrogen is added to blood from diabetic ketoacidosis or lactic acidosis, the excess hydrogen will be buffered by your bicarbonate. Over time, bicarbonate levels will decline. Okay, so these guys here are starting to soak up all of the hydrogens here. And what I mean by soak them up, they're not evaporating out of the blood, out of your blood vessels. They're just soaking up all the hydrogens so that they're not being an acid. Okay, so that's what these guys are doing there. Yeah, same thing right here. CO2, and there's that bicarbonate there. And you see, if this is coming from my big toe going to my lungs, remember, your body changes this into bicarbonate. And what bicarbonate does is if it sees any acid, hydrogen in the blood, soaks it up so that this and this become this, and therefore now this can now be just excreted and it's good to go, not causing any trouble. Renal control of acid base there, as we just said there, the kidneys can do anything. No, they can't. They can reabsorb the hydrogen as needed. They can reabsorb or secrete bicarbonate as needed. So the kidneys are hugely involved in the acid pH regulation there of the blood. Okay. As we stated there before, if the pH of the blood gets less than 7.35, you now officially have acidosis. If your pH of your blood goes just above 7.45, you now have alkalosis. Alkaline is a base, so that means base. All right. Respiratory acidosis. You'll have a look here. Hypoventilation, and you see, I don't know if you guys can see this here. Here we've got this is a happy lung. You can tell by his smile. So here we've got carbon dioxide and water. Okay, so we've got bicarbonate right here, which will produce the acid, and the bicarbonate ion right here. This is healthy lungs maintain healthy acid base. But have a look right here. If one side, if we've got excess hydrogen, okay, now we've got trouble. And this is where now the kidneys can excrete that hydrogen. They can get rid of it. Okay? And they can reabsorb the bicarbonate, which will now go back into the blood and soak up the rest of these. So this is what the respiratory there, what it can do there. What do we got here? Metabolic acidosis is caused by non-respiratory conditions. Kidney disease, uncontrolled diabetes. The body tries to correct this condition Buffer systems remove some of the hydrogen. Respiratory systems remove some of the hydrogen. Does what the best that it can do. Respiratory alkalosis. Again, same smiling lung. And here we've got on the other side, where we have too much CO2 levels decrease, driving the reaction to the left and causing a decrease in hydrogen. So we need this up. So this is where the kidneys can retain more hydrogen there. They can start dumping bicarbonate. Lots of things there that the kidneys there can do. And last slide here, metabolic alkalosis, increase in pH caused by non-respiratory disorders, persistent vomiting, loss of hydrochloric acid. You think about that. If you're vomiting uncontrolled, you know those, I hope you never experience it, the bad vomit where there's no more food anymore. It's bile. It's just stuff from your stomach, right? You're trying to get rid of hydrogen, right? And what if you do that too much? Now you've gotten rid of too much hydrogen. Now your whole system is now reverted into an alkaline or a basic. Now you're into alkalosis there, basic blood, which isn't good either. Okay, so, but again, buffers can donate hydrogen. Okay, just like you see this buffer right here. Okay, it can still donate a hydrogen if it needs to. That's the beauty of a buffer, is that it can accept a hydrogen or donate one. But whatever it's doing, it's maintaining the pH. Because if this is my buffer here and I dump all this hydrogen here, temporarily there's going to be a lot of hydrogen in the system, but then the buffer scoops it all up and the pH remains the same. Now, eventually, if you add too much hydrogen, you're going to have to add more buffer, because you're going to run out of buffer. But the body there with its carbon dioxide should have a lot. Yeah, that's good. And ladies and gentlemen, that's what we got there for that one. It's obviously not as intense as the first slide or the first PowerPoint, but that's where we're at right now. I'm just trying to think there for the test in 2 weeks. So next week there, your nervous system is due. What I might do is, because since it's all multiple choice and these kinds of things, I might get you guys to enter your answers onto Blackboard. You know what I mean? It's you guys could see your answers instantaneously instead of waiting, couple of days there for the answers for me to mark them myself. So I'll keep you guys updated on that. But other than that, I think we are in good shape. Next week there we have reproduction, which shouldn't be that bad. And we've got a bit of hereditary stuff. And I hope you guys are doing well. I'm going to stop recording. That's what I got there for today. And if you guys have